Hello everyone, welcome to Success Spectrum Academy. And in today's class, I'm going to take up that chapter that is Loci from class 10th ICSE Mathematics. Okay, so we know what is locus, right? So Loci is plural form of locus. So locus is a Latin word, right? It's no from which the word location, locality, etc. are derived. So if we'll say locus means locus is a path, okay, traced by a moving point. Okay, so locus is a path we can say traced by a moving point which moves so as to satisfy the creates means certain given condition, right? Yes, no, so means locus is a path traced by a moving point. So if your moving point is moved like this, so that this will be the locus. That is circular, you can say a circle with a center O. Okay, so if we'll take an example here, okay, that is a circle with a center O. So here I can say this, it is written is a locus of point which moves in nature that fixed point O is always equal to r centimeter. So here you can say that this point is moving this in a circular path, right? So this will be the locus of the center. So let a point move in a such a way that its distance from a fixed line AB is always equal to d centimeter. So here this line is given here A and B, right? Yes, no, we can take this point A and B. Okay. So if we have two lines like EF and CD, okay, so EF and CD, so clearly the locus of moving point is a pair of straight lines. So if we'll say, so here we can see this, that is EF and CD, there's two lines, okay, they are parallelly moving with line AB. So that is locus, we can say, of that line AB. Okay, so here CD and EF is parallel to move, means parallel to AB at a distance d centimeter from it. Now we'll discuss the theorem first. Okay, so what is the theorem first? So the locus of a point, okay, which is equidistant from two given fixed point is the perpendicular bisector of that line segment. So if we are taking 2 points like this, one point and here one point, another point. So this point is A and this point is B. Okay, so means these 2 points are joining here, okay, at point P. So you can see in the diagram in backside. Okay, so that is A and B both are joining at point P, and both are, we can say, equidistant from A and B. So both are equidistant from A and B. So if from point P, if we are producing a line, okay, that will, okay, join the line AB. So that will be perpendicular bisector of that line AB. Now here you can see, so the locus of a point which is equidistant from two given fixed point is perpendicular bisector of the line segment joining the given fixed point. So given, what is given here? So here I can say there's two fixed point A and B are given, two fixed point we have, that is A and B. Okay, and that point A and B both are equidistant from point P, we can say. So both the point are equidistant from point P. So here these things are given we have. So two fixed point A and B, and P is the point such that PA equal to PB. So this PA equal to PB, you can say. So what we need to prove? So to prove P lies on the perpendicular bisector of AB. So what we have to prove here? So P lies on the perpendicular bisector of AB. So this part is given, two fixed point A and B we have. So we need to do the construction first. So what we'll do? Join AB, okay, and find its middle point M. Okay, so here it is, this will be the midpoint, okay, M, okay, and join MP. So we will join this M and P line, this line will be joined together. Okay, now we need to prove here P lies on the perpendicular bisector of AB. So P is the point which is equidistant from both the point A and B, and that P will be lies on perpendicular bisector of AB. So perpendicular bisector of AB means we join the AB and find its middle point. We found it. So here I can say this M is the midpoint here. Okay. So M is the midpoint of A and B. So we need to prove it. So how we can prove it? So we did the construction here. So we join AB and we point the midpoint here M. Okay. So now statement in triangle PMA and PMB. So we have two triangle here. Okay, that is PMA and PMP. If you'll see, there are two triangles. Okay, so we have PA equal to PB. This thing is given. So PA equal to PB means this is equidistance from point P. So this thing is given here. PA equal to PB and MA equal to MB. So MA equal to MB, since M is midpoint of line AB, so we can say MA equal to MB. So this part is given. So in the reason part also we can write this part is given. By construction, M is midpoint of AB. Then PM and PM, this line is common for both the triangle PM and PM. So PM equal to PM. So this line is common for both the triangle. So we can say here triangle PMA is similar to triangle PMP. So by SSS side congruency axiom. Okay. So if these two triangles are means these two triangles are similar, so we can say angle AMP equal to angle BMP. So here this angle equal to this angle. So this angle and this angle are equal. So if we'll add both the angles, since it is in a line, okay, so this if we'll add both the angle, this will be 180 degree. So here I can see this AMP equal to BMP. So we can take this as equation 1 from CPCT it is proved. So now AMP and BMP equal to 180 degree. So AMP and BMP are 180 degree. So here we can say that AMP and BMP means this is both are, since both are equal, so 2 AMP equal to 180 degree. So AMP equal to 180 divided by 2. So we got this angle that AMP is 90 degree here. So this triangle, if you'll see here, okay, so this angle is how much? This angle is 90 degree. So if this angle is 90 degree means this is right angle we can say, and means we can say this line is perpendicular to line AB. So if it is perpendicular to line AB, and since M is midpoint of line AB, so we can say it is perpendicular bisector of line AB. So A and B is a straight line here, okay, from 1 and 2. So it is 90 degrees. So VMP is also 90 degrees. So PM is right bisector or angle bisector of line AB. This is what we need to prove here. So this is proved. So conversely, if we'll see, that is part B of this theorem. So that is also means true. Every point on the perpendicular bisector of AB equidistance from A and B. Okay. So every point, okay, on the perpendicular bisector of AB is equidistant. Now see this. This is part B of the first theorem that we already proved. Okay, so every point on the perpendicular bisector of AB. Okay, so here this line was AB and this was the point P. So now there is another point Q. There is another point we can say R. So every point from this AB that will lie in this perpendicular bisector will be equidistant. Okay, so what we need to prove here? Okay, so we need to prove that PA equal to PB. That is converse of the theorem 1. Okay, so what we will do in this? So here I can say this. So here it is given that two fixed point A and B. So here two fixed point A and B are given. Okay, so now MQ. So here I can say this MQ is perpendicular bisector. We can say means here it is 90 degree. This one also 90 degree. So it is perpendicular bisector we have. Okay, or it is lie in the midpoint. So now this is the bisector of we can say AB. So here it is PM equal to PB. Sorry, PM equal to MB here. Okay, so bisector of AB and P is any point on MQ. So P is any point on MQ. So we can take a point here also like R. We can take any point here also S. So these will be equidistant from line AB. So construction, what we are doing? Okay, so join PA and PB. So we are joining this PA and PB. Okay, so statement in triangle PMA and PMB, we have PM equal to PM. This is common line, PM equal to PM. Okay, angle PMA equal to angle PMB. Do both the angles are 90 degree. So here both the angles are 90 degree. And MA equal to MB. So here you can see this MA equal to MB. These are means, since M is midpoint, or we can say PM is perpendicular bisector on line AB, so it is divided into two equal parts. So MA equal to MP, since M is midpoint of line AB, so it is given. So we can say the triangle PMA is similar to triangle PMB. So from which axiom it is? So it is from side angle side axiom. Okay, so here it is from side angle side axiom. So PMA and PMB are similar. Hence we can say PA equal to PB. Now we have two sides. So these two sides of that is similar triangles are equal from CPCT. So this is what we need to prove here. Okay. So what we can that any point lie on the perpendicular bisector of a line AB that will be equidistant from A and B both. Now the second theorem, that point equidistance from two intersecting line. Okay, so the locus of a point which is equidistant from two intersecting lines. So here suppose we have this line. Okay, so now we have two intersecting lines, we can say AB and CD. Okay, so these are two, means we can say lines AB and CD. Okay, so the locus of a point which is equidistant from two intersecting lines is the pair of line bisecting the angles, okay, formed by the given line. So these two lines are forming an angle. Okay, so this is the, we can say, locus here. Okay, so both are equidistant from these 2 points, we can say. So this will be the bisector of this angle. This is what we need to prove here. So here you can see this, every point which is equidistant from two intersecting lines, bisector of the angle between the line. So what is given here? So two straight line B and C intersect a point O. So here I can see this, it is intersecting at point O. P is a point on interior of angle BOD. So here this angle is BOD we have. So this is P, we have a point here. Okay, such that PM is perpendicular to AB. So PM is perpendicular to AB and PN is perpendicular to CD. So P is perpendicular to AB and PN is perpendicular to CD, and PM equal to PN. So now what we need to prove here, that P lies on bisector of angle BOD. So P lies on bisector of angle BOD. So what the construction we need to do? So here we can join OP. We are joining the point OE. So I can see the statement integral M and ONP. Now take two angles. Triangles we have. OMP equal to P is given two perpendicular. So here are 90 degrees. So both the angles are equal, we can say. And OP and OP both are common for both the triangle. So by RHS axioms, okay, of C, you can say triangle OMP and ON are similar. Okay, so here angle MOP equal to angle NOP. So here I can see that this angle and this angle will be equal. So these two angles are equal, means P lies on bisector of angle BOD. This is what we need to prove here. Let's prove now. So here you can see the another theorem, that is part B of second theorem. Conversely, we can say every point on the angle bisector of two intersecting lines, okay, or is equidistant from the line. So same thing we need to prove here, that PM equal to PN. So PM equal to PN, that is angle bisector. So means both the angles are equal. Okay, in statement we can write that. Okay, so we can prove that both the triangles are similar, and by the CPCT we can say that PM equal to PN. Okay. So here you can see this. Conversely, we can say every point on the angle bisector, every point on the angle bisector. So we can take P, Q, R, S, any point. So here also like this. Okay, so this will be the perpendicular bisector of two intersecting line is equidistant from the line. So two lines AB and CD intersecting at point O. O is bisector. So here this line O and E is bisector. Okay, and P is any point. We can say P is a point on OE. So PM perpendicular to OB and PN perpendicular to OD. So we are taking two perpendiculars here. Okay, these two. So we need to prove that PM equal to PN. So these two perpendiculars are equal. So here you can see this in statement part. We can write here the triangle OMP and ONP. We are taking these two triangle OMP and ONP. That angle MOP equal to angle NOP. Since OE is bisector, so these two angles will be equal. So now these two angles are equal. So we can say angle OMP and ONP are also equal. So OMP and ONP are equal since it is perpendicular here. So this will be 90 degree. This will be also 90 degree. OP is common. So this line is common for both. So here this line is common for both. So this is, we can say, equal. So hence we can say that triangle OMP and ONP are similar by angle side angle axiom. Okay, so since by CPCT we can say that PM equal to PN. This is what we need to prove here. So it is proved now. So here I'm taking the first question. So we had the two theorem that I explained already. Okay, so means if you are finding this video interesting, you can like it, subscribe it, and share with your friends so that they will get benefit from this video. Okay, and I'll give you more video in my channel. Okay, I'll put more videos of class 10th ICSE as well as CBSE also. Sooner I'm going to upload for 9th as well, and for 11th and 12th also. That is physics and chemistry and mathematics I'm taking. So these three subjects will be there in the video. So you can subscribe it and share it with your friend. Okay, and you can press the bell icon so that you'll get notification as well. So here you can see this is the first question here that I'm going to discuss. It is given in the given figure, triangle PBC and triangle QBC are two isosceles triangles. Okay, so as I proved that theorem already, that theorem 1. So now from that theorem we have a question here in a given figure that triangle PBC and triangle QBC are two isosceles triangles. Okay, so isosceles triangles means that two sides are equal, means PB equal to PC, similarly QB equal to QC. So we need to show that the line PQ, okay, when produced bisect that BC. Okay, so that BC will be bisected by the line, okay, PM. Okay, so P get produced, so PQ will be joined, and that Q will get produced to BC, line BC. When we are joining it, okay, we'll find out a point that is M. So from P to M there is a line that is PM, we can say, that will be perpendicular bisector of, we can say, BC. That's what we need to prove here. So now we can go for the detailed explanation. So here you can see. So first thing, we have to do the construction here. So we need to join the PQ and reduce it to meet BC. So we are joining this PQ and we are producing it to line BC. So it is joining at point M here. Okay, now we are taking the triangle PBC and QBC are isosceles, means it is given, we can say. So these two triangles are isosceles triangle on same base BC. So here you can see that this is the same base BC. These two triangles are aligned. Okay, so we have PB equal to PC and QB equal to QC. So first we are taking PB equal to PC. So since PB equal to PC means P is equidistant from point B and point C both. Okay, P lies on the perpendicular bisector of PC. Means this is proved now. This point P is lying on the perpendicular bisector of BC. Similarly, if we are taking the triangle QBC, so here we had the triangle PBC. So now we are taking the triangle QBC. So in QBC, if QB equal to QC, so Q is equidistant from point B and C. So Q lies on the perpendicular bisector BC. So now this is also proved. that QA is also lying on the perpendicular bisector BC. Now here you can see this, we can say this PQM is perpendicular bisector of BC. So this PQM is perpendicular bisector of BC. Since P and Q both are lying in this line, okay, so now this two triangles means we have, right? So this line will be perpendicular bisector of that line BC, or PQM bisect BC and perpendicular to BC. So it is bisecting BC and it will be perpendicular to BC. So both the angle will be 90 degree here. Now here you can see this. This is the second question we have in the PBC equal PBC triangle QBC, means triangle PBC, triangle QBC, triangle RBC are three isosceles triangle. Now same thing here you can see this P, Q and R. Okay, we need to prove that are collinear. Collinear means they are lying in the same line, means they are perpendicular bisector to BC. So what we will do in this? So first thing here, triangle PBC, triangle QBC and triangle RBC are isosceles triangles, okay, on the same base BC. So here, triangle PBC, triangle QBC and triangle RBC isosceles triangle. These are isosceles triangle. So what we can say in this? PB equal to PC, QB equal to QC. So PB, QB equal to QC and RB equal to RC. So here PB equal to PC, QB equal to QC and RB equal to RC. So we can consider here, let L, okay, be the perpendicular bisector of BC. So if it is perpendicular, L is perpendicular bisector of BC. So if I'm taking PB equal to PC here, okay. So from PB equal to PC, what we can write? That P lies on perpendicular bisector of BC. In the line L, okay. Similarly, P lies on L if QB equal to, now we can take equal to C. Here also we can say Q line equal to C. From this we get R on. So these are the lines. So here P, Q, R lie on the same line L, hence we can P, Q, R are collinear. Answer. So here you can see this another question we have, that construct a triangle ABC which is means in which BC is 6.5 centimeters. So how the construction will happen? So you, for this construction part, you have means you need scale, okay, a protector, a compass, okay. So from that you can draw it, okay. For a 6.5 centimeter line you have to take, means you can draw a line, and from that means mark the scale that 6.5 centimeter you will take, and using the protector you can draw a angle that is 60 degree, okay. So you can draw it that is 60 degree, and AB equal to given here 5 centimeter. So AB is also given 5 centimeter. Okay, so first thing what we have to do here, so here I can see this AB is given 5 centimeter. So first we need to draw the line BC, that is 6.5 centimeter. Construct an angle CBD using, either you can use the compass or you can use the protector, and from that you can draw it 60 degree, and set off BA, means BA equal to how much? 5 centimeter. So that also you have to do. Then second question here, construct the locus of point, okay, at a distance 3.5 centimeter from A. So now if we have, okay, construct a triangle ABC. So we drawn that line BC 6.5 centimeter like this, 6.5 centimeter you can consider this. Okay, now another angle we have to do here, we have to draw it, so it is 60 degrees, so this angle will be 60 degree, and from this we can take a line like this will be the line here, 60-degree angle. So now mark a point A and join this line also, so it will be a triangle like this. Okay, so it will be a triangle like this, so this is ABC we can say. So with the angle 60 degree, means angle B equal to, means angle ABC equal to 60 degree. So now in this line, okay, means here this line if we'll take, that is with A as a center and radius will be 3.5 centimeter. So A will be the center, and from that we have to draw a circle. So you can use your compass. So one tip will be at the A, at point A, and you can draw a circle, okay, with, by the help of compass. Okay, that will be 3.5 centimeters. So you can mark that from using your scale, that will be 3.5 centimeter, and draw the circle. Okay, so that will be, we can say, locus. So with A as a center and radius 3.5 centimeter, draw a circle. This is the required locus of point at a distance 3.5 centimeters. So that will be at a distance 3.5 centimeters. Similarly, another question we have, third, construct the locus of a point equidistant from AC and BC. So equidistance from AC and BC. So if it is equidistance from AC as well as BC also. So now I'll show you it in the diagram. So here I can see, as I told you, that we have to take a line BC, that is 6.5 centimeter here. Okay, from that, means using, either you can use your compass or your protector. From that you can draw a 60 degree here. Okay, so you can mark it as 60 degree and then draw a line. Okay, and that line AB equal to how much, means here, okay, you need to mark it at 5.2 centimeter, means here, sorry, this will be AB is given here 5 centimeter. So AB you need to take 5 centimeter, BC is given here 6.5 centimeter. Okay, now join the point A and C. Now we have the required triangle ABC. So we are getting the triangle ABC, and then here you can find out the AC as well. Okay, so means by using the scale, that length of AC you will get. So now here you can see that you have to draw the bisector CX of angle BCA. So how we are drawing that angle bisector? So if any angle is here, right, is no, we are drawing the angle, then using the compass tip, okay, mark it like this, then another tip here, then mark it like this, and this will be the bisector. So now here I can see, draw the bisector CX of angle BCA. So where the BCA, this will be the BCA here. You can see that this is the angle. So here you can mark it like this. From here we can mark it like this and draw it. Okay, so that it is touching the circle here. Okay, focus we can say, and mark this point X, and here you can mark this point as Y. Okay, now you have to join this AX and AY, and these AX and AY are equal. So draw the bisector CX. So then CX is the locus point of equidistance from AC and BC also. So here it is equidistance from A, C and BC. This point we can say this will be equidistant from AC and BC as well. Now let CX cut the circle at X and Y. This was the fourth question, okay, we had. So then clearly AX and AY is 3.5 centimeter. Thus X and Y is equidistant from A and equidistant from AC and BC as well. So it is equidistant from A as well as equidistant from AC and BC also. Okay, so XY, you can measure it by the help of scale, and this we will get 5.2 centimeter. Okay, now here I can, okay, see this chapter means the conceptually and numerically I explain everything. So date means in the remaining classes I'll give you the solutions as well. Okay, then this will help you in the upcoming exam, that is for ICSE board now, okay, for class 10. So this chapter Loci is over. If you like it, please share with your friend. Okay, this video will help them as well in the exam, upcoming exam. Okay, and don't forget to subscribe my channel. Very soon I'm going to upload all the chapters video here for physics, chemistry and mathematics. You'll find it for class 9, 10 and 11, 12 as well. Thank you so much. Thank you for watching.